Hello everyone, this is Vasant, a nine-pointer at IIT Bombay from the Department of Civil Engineering. Today we are going to solve one more problem on statically indeterminate structures. So this is the problem. You can see here. Let us read the problem first. So a rigid bar AB. So this is a rigid bar. Okay. So what is the meaning of rigid bar? Means no deformation in the bar. But I already said in first few lectures, that actually no body is rigid. But why given that the body is rigid here? Means here there are negligible deformations that we can say the body as a rigid here. So that's the reason why he said rigid. Okay. So our values will won't affect that much by assuming this bar as rigid. So this is rigid bar and length. Let us solve in variables. So forget about these values. Is hinged to a support, means this is pin support or hinge support. Pin support means it only resists forward and upwards, horizontal and upward displacements, but it won't resist the movement, right? So it can, this is the hinge support, then it can freely rotate. Okay. So to stop this rotation, we need to have one more support. So that is, we can say this is given, this is one more support given. But if you see here, there is one more support given. See, if it is going like this, you hold like this, so then it is instable, right? It is stable and it is statically determinate. But you are providing one more support, right? So it is statically indeterminate to 1 degree. So you need to have one compatibility equation along with the equilibrium equations. So both wires have the same cross sectional area. So both wires have same cross sectional area and same modulus of elasticity. So same cross sectional area, same modulus of elasticity. Okay. So the wire C has length h and wire at D has 2h length. Horizontal distance are given as C, D, and total length is L. So determine the tensile stresses sigma C and sigma T. So how we know that here the stresses are tensile? That we need to find out first. See, because the stresses are tensile because see, you are applying load P like this. So it is here, it is in equilibrium. So you are applying load like this. So you are trying to elongate the members connected to the point C and D, right? You are trying to move this rigid bar down, but because there are members at C and D, they will resist, right? So because of that, there will be some elongation because it is downwards. So this is the elongation means tensile stress. That is how we can identify whether it is a tensile stress or compressive stress. So next, find the downward displacement. Okay, let's go forward. So see, this is, let us draw the diagram. So this is the support. Here there will be C. So there will see from this bar is under tensile force, right? So it will be PC and PC. So this will be equal and opposite PC. So similarly, it will be PD. Okay. So here the bar will be PD and PD. Okay. Understood? And this length. So see, because of this load P, it will deform. So it will deform like this. This deformation will be very small, that you need to understand. Theta, PD, PD, this is P. So this is length, this is C length here to here, and here to here it is P, and whole length is L. Okay. So now we can apply moment equilibrium equation at point, suppose this point is A, this is P. So moment equilibrium equation at point A, sigma MA is equals to PC into C plus PD into D minus P into L is equals to 0, right? This is moment equilibrium equation. So PC C plus PD D will be is equals to PL. This is one equilibrium equation. So see, here the unknowns are PC and PD. We already know the value of C, D, P, L. So we need to find PC and PD, we need to have two equations, but the equilibrium equation is only one. So you may say that I will go and apply sigma fx is equals to 0, sigma Fy is equals to 0. But do you know that here there are reactive forces Ay and Ax? So then two unknowns will add, two equations will also add, that will cancel each other. So saying like this is also correct, right? So there are only one equilibrium equation here. So we need to have one more equation to solve PC and PD. So that is compatibility condition. Compatibility condition over here is this. See, if the rod at C and D elongates, they must satisfy the compatibility at conditions. Right? Compatibility conditions given by the supports. Because the bar AG is rigid, that will deflect only in straight line, right? Like this. So it will be straight. So from that we will get one equation. So this is theta, then this will be elongation of rod at C. This will be elongation of the rod at D. Okay. So this downward displacement is let us say dB. Okay. We won't write it as del B because you may you confuse that it is also a elongation, but it is not elongation because there is no rod over here, right? So from this we can write del C by C will be is equals to del D by D, right? From this is, so from this you can write what is del C. Del C will be PC into length of rod at C, H, divided by A into E. Similarly, del E will be 2PD into H divided by AE because the length is 2H. So you can apply over here. You will get PCH divided by AEC is equals to 2PDH divided by AEB. So from this we will get PC divided by C is equals to 2PD divided by D. Okay. From this you can write PD is equals to PC into D divided by 2C. Okay. This is one more equation we have. This is equation 2. So let us apply equation 2 in equation 1. So then PC into C plus PD. So PCB square divided by 2C is equals to PL, right? So equation 2 in equation 1. So that will, if you take PC common, this will give rise to PC square plus B square divided by 2C is equals to PL. That will give rise to PC is equals to 2PLC divided by 2C square plus B square. Okay. So this is PC. This is PC, right? Now we need to find out PD. This is P. We need to find out PD, right? So we already know that. Put equation 3 in equation 2. The equation 2 is PD is equals to PCD by 2C, right? So you can apply PD equals to, what is PC? PC is 2PLC. 2PLC divided by 2C square plus D square. So this is PC into D by 2C. D by 2C, right? So 2C will get cancelled. So you will get PD is equals to PLP divided by 2C square plus D square, right? This is equation 4. So now we got PC and PD. Now we need to find out, see, let us go here. So first is we need to find out tensile stresses sigma C and sigma D, right? So first A. So sigma C will be is equals to, sigma C will be equals to PC divided by A, right? So that will be is equals to 2PLC divided by A into 2C square plus D square. Similarly, sigma D will be is equals to PD divided by A. That will be is equals to PLD divided by A into 2C square plus D square. Okay. So this is part A. What is part B? We need to find out DB. So see, from that triangle only we can write dB divided by L is equals to del D divided by D. So what is del D? That is, we already know elongation of D as 2PDH divided by, so 2PDH divided by AED. We already calculated the value of PD, so we put over here, that will give 2PLDH divided by AED into 2C square plus D square, right? So DD will cancel, we get 2PLH divided by AE into 2C square plus D square. So this is part B, right? So with this we completed today's problem. In next lecture we are going to solve one more challenging problem. Until then, take care. Bye bye from 9 Point.